Hello student, very good morning to all of you. Do you remember what were we discussing yesterday? I think we were discussing about the Perkin condensation reaction or the Perkin reaction. What are the starting material required for the synthesis of cinnamic acid, because the resulting compound obtained in a Perkin condensation or the Perkin reaction is a cinnamic acid, and which is one of the compound which exhibit or which shows as a medicinal property. And during the synthesis of cinnamic acid we are getting the side product that is acetic acid, that is also as a useful chemical obtained during this process, and therefore this synthesis is useful. And these synthesis or Perkin reaction proceed via Carbanion, because we are studying the reaction involving as a Carbanion. First one we have learned, that is aldol condensation reaction. Second one is a Claisen ester condensation reaction, and third one is a Perkin condensation reaction. In between we have learned that is a Dickmann cyclization reaction. So these are the reaction, what are their starting material, what would be the intermediate used during the formation of the product, what are the reagent or the bases are used. So that are the point you have to remember. And now what we are going to discuss today, look at here, that is a malonic ester or the diethyl malonate. And first of all let us see the structure of the malonic ester over here, and because the structure is an important one, and once you know the structure and you can take the starting material, you can start the starting material in such a way that you can arrive the final product, which is a malonic ester. And this malonic ester is called as a synthetic reagent. Why it is called as a synthetic reagent? Because it is useful for the organic compound. We can use it, is a versatile synthon or the reagent to prepare, to synthesize different organic compound, and that's why it is very very important as far as synthetic organic chemistry is concerned. And the structure of this malonic ester, C double ETO, then C double bond O, then CH2, C double bond O, and this OET. This is the structure of malonic ester. Remember here, this is the structure of malonic ester. And now I already told you that reactive methylene group, right? Reactive methylene group. Reactive methylene group. What does it mean? What do you mean by the reactive methylene group? Let me tell you over here. Look at here, reactive methylene group means what? The methylene group which is flanked by two electron withdrawing group is called as a reactive methylene group. For example, cyanoethyl acetate or acetoacetic ester or malonic ester, they exhibit this type of the group. If you look at, this is a structure of malonic ester. This is a structure of malonic ester, and it has a CH2 group, this CH2 group. And this CH2 group, if you observe this structure carefully, what do you see over here? Look at there, on both the side there is a carbonyl group, and as we know that carbonyl group is a electron withdrawing group, and this methylene group present in between, it is flanked in between as a two electron withdrawing group, and therefore whatever proton, whatever hydrogen present, hydrogen present over there, they are highly acidic one, and by using as a base we can generate the carbanion, and that carbanion further treated with the alkyl halide, or what we can call it as a acyl halide, there is a formation of the new carbon-carbon bonds over there, and that's why we are synthesizing as a new organic compound, and that's why it is having as a new synthetic route for obtaining, for synthesizing as an organic compound. Later how, when this the malonic ester, suppose the base is used over there which can abstract the proton. Let me explain this reactive methylene group, this concept once again. Here ETO, then C double bond O, CH, for sake of convenience, to show the clarity. That's why I am writing this hydrogen atom in this manner, then C double bond O, OAT. Now the base, any base we can use generally. In this particular case, for the generation of the carbanion, we are employing the strong bases. Here what it will do, that base, the base will abstract the proton and form as a carbanion. And after that, what you are going to get over here, ETO, then C double bond O, CH minus, and then C double bond O, OET. And this is a carbanion, right? The carbon atom, this is known as a carbanion. The carbon atom carries as a negative charge, is known as a carbanion, as we know that. And these carbanion, at the beginning we have seen, after the method for the formation of the carbanion, we have already learned that the factor stabilizing the carbanion, number 1, S character of the carbanion, number 2, inductive effect, number 3, resonance effect, number 4, aromatization. These are the factors which can stabilize the carbanion. Now out of that 4, which one will be the stabilizing this carbanion? Look at over there, this carbanion is flanked, is present in between as a 2 electron withdrawing group, and it is stabilized by the resonance effect or minus R inductive effect or minus R inductive effect. And therefore we can draw the structure like this: ETO, then C double bond O, then CH double bond, now CO minus, then OET. And another way you can draw this resonating structure, again this negative charge coming over there, and then again the negative charge resting on that carbon atom, ETO, C double bond O, then CH minus charge, then C double bond O, OET. Again we can draw the resonating structure, this negative charge coming here, forming as a double bond, and then negative charge on that oxygen atom, so that you are going to get over there ETO, then O minus charge over there, then here is a carbon-carbon double bond CH, C double bond O, and OET. So in this way, this why it is called as a reactive methylene group, because after the formation of the carbanion, that carbanion is well stabilized due to the minus I and minus R effect or by the resonance effect, and therefore this is known as a reactive methylene group, or it is known as a synthetic reagent. Synthetic reagent means it is a versatile synthon, variety of the organic compound we can synthesize by using as a this reagent. Now synthesis of malonic ester. Now what we have learned here the structure of malonic ester, and we have also discussed the concept of reactive methylene group. Now we are moving toward the synthesis of malonic ester. How do we prepare malonic ester in the laboratory? That we are going to discuss right now here. So let us see here synthesis of malonic ester. Synthesis synthesis of malonic ester or diethyl malonic ester. What will be the starting material for the synthesis of malonic ester? The starting material is used as that sodium chloroacetate. Sodium chloroacetate is used as a starting material for the synthesis of malonic ester, and that sodium chloroacetate react with hydrogen cyanide and forms the sodium cyanoacetate, and that sodium cyanoacetate which on heating with ethyl alcohol in presence of sulfuric acid gives malonic ester, that is a diethyl ester. So now let us look at as a starting material. What is the starting material is taken here? Here is, this is a starting material CH2Cl. This type of the compound I am written over there. The name of this compound is a sodium. This is a salt, sodium salt of acetate, sodium chloroacetate, which is the starting material is taken or used for the synthesis of malonic ester. Now this will be further treated with hydrogen cyanide, SCN, as we know that it is a very poisonous in nature. So that is in the gaseous form. What is going to happen? This is a here positive charge, here positive, and here is a nucleophile, and this nucleophile is going to attack at that carbon atom. There is a departure of this type of, because this is a substitution, nucleophilic substitution type of the reactions are there, and therefore you are going to get over here C double bond O Na. Here is a plus and minus charge on the oxygen atom, and then there will be a CH2 and cyanide group over here, and that is called as a sodium cyanoacetate. This one is known as a sodium cyanoacetate. This is the name of this intermediate or this compound, and this compound further treated with C2H5OH ethanol in presence of H2SO4, that is a sulfuric acid used over here. And what you are going to get in this case, after doing this treatment over here, you are going to get like this COO, then ET over there, then CH2 COO ET. What is going to happen? The H2SO4 can hydrolyze this cyano group into as acid, and that sodium salt further converted into as acid ethanol esterification reaction carry out over here or taking place in this during this reaction, and finally we will get the structure, and the side product is obtained here is a this one NH4 ammonium salt is generated over there, but this is the structure of malonic ester. This is a malonic ester, and just now we have seen as a how the malonic ester is synthesized in the laboratory. What will be the starting material? This we have seen in detail. So now is a synthetic application. What are the synthetic application of this malonic ester? That we are going to learn over here. Now just now we have seen the synthesis. Now we are going to learn as a synthetic application of malonic ester. Now I am writing over here synthetic application. Synthetic application. Now by using as a malonic ester, how we can prepare the different organic compound in the laboratory, that we are going to learn over here. First one, synthesis of alpha substituted acetic acid or monoalkylation. First application, synthetic application we are learning here. One is a synthesis of alpha substituted acetic acid, or what we can call it as a monoalkylation, or this in the exam, how the question will appear over here, how will you prepare the what we can call it as a alpha substituted acetic acid, or what we can call it as a, how will you prepare the propanonic acid, how will you prepare the propanonic acid. So that type of the question may appear in the exam. So let us see over here. And now as we know that the structure of malonic ester, ETC, then C double bond O, CH2, C double bond O, then OET, that there are the different reagent we are going to use over here. First reagent we are going to use here sodium alkoxide, right? First one. Then second reagent we are going to use here, that is the alkyl halide, right? Alkyl halide. At the beginning we have seen that in all the reaction, the first step will be the formation of the carbanion from malonic ester and the making it to react with the alkyl or the acyl halide. So that is there. And the third step, third reagent is going to take place over here, that is which is a hydrolysis, H2O in presence of the H plus. And now the fourth step taking place over here, that is just as a heating, means that is called as a decarboxylation, means removal of carbon dioxide, CO2 is evolved. This process is known as a decarboxylation, and by using as a base, first step is a formation of the carbanion, second one treated with the alkyl halide, then mono substituted reaction takes place over there. Third reagent we are adding as a hydrolysis, means ester group is converted into as a acid, and the fourth one, that is a heating process, or during that heating there is a evolution of carbon dioxide. That process is known as a decarboxylation. And finally doing all these things, what you are going to get over here, this CH2 and there are C double bond O, then OH. This type of the compound we are going to get during this process, and this is called as alpha substituted acetic acid. This is called as alpha substituted acetic acid, right? Alpha substituted acetic acid. If you observe this structure carefully, what do you see over here? The group which is first group, which is a CH and then C double bond O group, which is coming from the malonic ester. This is a structure of malonic ester. This is a structure of malonic ester, and this there are two parts are there. Now is a look at here R group, that is a alkyl group, and where from it is coming? It is coming from the alkyl halide. This is known as alkyl halide, right? Alkyl halide. And during that analysis you have to plan how, and these are the noticeable point regarding this. So by using this concept, by using this is a starting material, you can use the different organic compound with the help of this malonic ester, because it consists the CH2 reactive methylene group. And therefore now let me how will you prepare the propanonic acid by using malonic ester? Let me write the question over here. Suppose how will you prepare? How will you prepare propanonic acid using malonic ester. How will you prepare propanic acid using malonic ester? This is our question. How will you solve? How will you synthesize? How will you prepare that propanic acid? Let's begin over here. Now we are talking about the synthetic application of the malonic ester, and now let us see over here. First of all, let us see planning of this. What would be the structure of propanic acid? Let us see, first draw the structure of propanic acid here. CH3, then CH2, C double bond O, and then this OH, right? And if you analyze this compound by observing this clearly, what do you see? I am writing one of the hydrogen atom over here so that you can understood the meaning of this. How do you analyze this? Look at here. I am making two parts over there, and the two blocks clearly indicate that. Look at here. One part suggests that CH double bond OH. Another part I am showing that is a methyl group over there. This is a alkyl, because this part is coming from the alkyl group and this part is coming from the malonic ester. What the question says here? The question says, what does the question says here? How will you prepare propanic acid using malonic ester? This question says that how will you prepare the malonic ester by using the malonic ester. And so let us synthesize this compound. This compound I am writing over here. So CH3, then CH, for sake of convenience I am writing here. So you can notice this compound, what I mean to say over here, or what I mean to how do I synthesize this one propanic acid. So those are the students, if they understand the basic concept regarding this malonic ester, they can easily prepare this type of the compound. If you pay the attention from the beginning, then and then it's the organic chemistry is a very, very easy. And if you understood the basic regarding the organ, now is a malonic ester. Question we know that, right? Now I am first one is what is our starting material or the substrate or the what we can call it as a reactant is a malonic ester. Let us see over there. CH3, then not CH3. So here the malonic ester, as we know that ATO, then C double bond O, CH2, C double bond O, and sorry, not O, that is OET, right? So this is the starting compound. This is malonic ester. This will be the malonic ester, right? This is a structure of malonic ester. What is our first job, or first we are adding, that is a sodium ethoxide, which is a strong base. What that sodium ethoxide do over here? Now I am adding all the reagent. First one this, then second would be the this one CH3 Br, then third one hydrolysis H2O in presence of the H plus, and the fourth one just as a heating means minus CO2, that is a decarboxylation, and finally we are going to get the product CH3, then CH2, C double bond O, OH. This is known as a propanoic acid. Look at, so easy and very easy to synthesize this compound in the laboratory. Now let us look at first what are the reagents. There are the 4 reagents I have used over there, and I got the propanic acid is a final product over there. Now let us look at as a mechanism over here. So for the mechanism point of view, I am writing over here suitably this compound. Let us see over here ETO, then C double bond O, CH, 1H over here, I am writing C double bond O and OET. Now what we are adding over OET minus, which is a base which will abstract the proton and form the carbanion over there. Now look at here, ETO, then C double bond O, then CH minus charge over there, C double bond O and OET. Here maybe as a, you write as a sodium or not, that type of the, you write sodium Na plus or minus charge over there, you write or not showing that, it means that organic chemist, you have to assume, you have to consider it is there. So these are the some of the convention to show the mechanism of the organic compound, and therefore now this is in the first step what we did, we have used, this is the reagent, sodium ethoxide, it is the reagent used there for the synthesis of that malonic ester. Now look at here, right? Now another method, what is that we are treating, that is this one, treated with methyl bromide, methyl iodide, methyl chloride or methyl fluoride, you can take whatever you see. And now this negative charge is attacking on that because that carbon atom is electrophilic in nature. As we know that it is a nucleophile in nature, the substitution reaction takes place and we are going to get over here this one ETO, C double bond O, then here CH2, here I am writing this not CH only, and here methyl group, and then C double bond O, OET like this. Understood this one? Okay. Then now this is a alpha substituted malonic ester we got, and after that we are hydrolyzing it, H2O in presence of H plus. This process is known as a this one is known as a alkylation, and this process is known as a hydrolysis. This process is known as a hydrolysis, and this process is known as a formation of carbanion, right? First one. Now after the in the hydrolysis, what is going to happen? There is a ester group here also as a ester group. Ester hydrolysis, it means that ester group is converted into as a acid. That's it. Here H O, C double bond O, then CH. That is a step we are showing. This one. Hydrolysis. Now this CH, then now here writing CS3, then C double bond O and OH, right? This is the thing. What we did only, we converted that ester group into as acid. That's it. That is the meaning of hydrolysis that carried out. And after that, what we can do over here, there is a heating. So here we got as a dicarboxylic acid. This dicarboxylic acid, right? And what is going to happen here? Heating, there is a removal of carbon dioxide. This process is known as a decarboxylation. This is called as a decarboxylation. This is known as a decarboxylation. In the decarboxylation, what is happening here? This forming as a double bond over there, and this revolving around it, and there will be a minus charge, means this hydrogen atom then goes over there. So there will be how we are going to get, there is a carbon dioxide is evolved during this process, and now CH minus, then CS3, look at here C double bond O and OH over here, and this further is treated with hydrolysis H2 in presence of H plus. This process is known as a protonation. This process is known as a protonation, and this will pick up the proton from here, and we are going to get here CS3, CH2, then C double bond O and the OH. This is nothing but our propanoic acid. So this is the product we got over here. I think with this we have completed how the malonic ester. But here if you see again over here, this part I am writing as a H over here. This if you See this carefully. This type of the part, the CH double bond OOH part in the final product is coming from the malonic ester, and the CH3 part is coming from the alkyl part. And in the second noticeable point over here, in the hydrolysis step, the ester group get hydrolyzed to give dicarboxylic acid, and which on heating lose one CO2 molecule and form alpha disubstituted acetate. Because there are the two acidic group are there, but in the decarboxylation only one group loses the carbon dioxide and getting such type of the carbanion over there, and that will be treated with in the final product. One of the alpha hydrogen has come as a result of decarboxylation step followed by protonation. This is we have done, we have carried out this reaction. That step is known as a protonation, and by using 2 moles of alkyl halide we can get disubstituted acetic acid, means dialkylation, that we will see in the next lecture. I think with this we have completed this part over here. So how do you prepare this type of the propanonic acid? I think you might be understood this one. Remaining one we will see in the next lecture. Thank you. Have a nice